next week. Let's see how far we get with the review assignment first before I give you that, but it'll definitely be Tuesday or Wednesday. Okay, so the questions you're going to see today, they all of them have multiple methods or multiple ways of solving them, and I'll go through each method for each question so you get to see it. All right. Question one, and this is basically these are questions from last year's test, so you could kind of get a feel for what my questions look like. Um, which equation is represented by the accompanying graph? And they give you this picture, okay, and then they give you four different options, right? So one of these things should represent this picture. Uh, okay. Well, something that we should know is that this image is an absolute value function. It's like one of the first lessons we did at the very beginning of the year. We talked about the parent functions, and this one, based on its shape, we can tell that it's absolute value. So I know this is something to do with absolute value. Okay, I know that much. And even if you didn't, you could still get away with it. What you can do, I'm going to take the easiest approach. The easiest approach first would be just to use Desmos. I could simply take my four choices, okay, and I could substitute these four choices into the computer and see which one of these four options generates this picture. Okay. Um, so since I know it's absolute value, I can save myself the trouble and not check D because D is not absolute value. So I know it's not going to work. So I have A, B, and C to check. One of these functions is going to give me this diagram. It's important to note the vertex of the absolute value, the turning point, and that occurs, it's even labeled. The vertex here is 3 comma 1. So I'm going to graph and look for one that has a vertex of 3 comma 1 and is placed exactly as this one's placed in the coordinate plane. So I have to try A, B, and C. So let me go to Desmos and put all three of these items into the Desmos, and we'll see which one gives us this picture. That's the plan. All right. This is probably the easiest way of doing it because by doing it this way, you don't have to remember any formulas or anything. You can just plot the choices and see which one works. All right. And this is just doing the example in a visual way. So let's do that. Let's go to Desmos. We'll put the value in, and we'll see which one gives us the proper picture. Okay. So okay. Let me give it a second to load up. Okay, so I hope you can see Desmos at this point. All right, and there were three choices. There were actually four, but there are only three that I'm going to bother with because one of the choices was not absolute value, and I know that this is absolute value based on the shape. So the three possible options are the absolute value of x, the absolute value of x with the -3 on the outside. Uh, this one has a vertex. This is not the one that I saw in the picture, right? The one I saw in the picture was 3 comma 1 or something like that. It was up here. So this is not in the appropriate place. I know choice A is incorrect. Choice B is x -3 inside the absolute +1. So x -3 is inside and the +1's on the outside. Okay, the green one, does look like the one on the test paper, right? With the vertex of 3 comma 1. This does appear to be the proper one. And the last choice, C, let's just make sure C is wrong. It should be wrong. X +3 inside -1. Um, X +3 and then -1 on the outside. And that's not what we saw, right? The one we saw had a vertex of 3 comma 1, like the green one has. The blue one is a different vertex, and the purple one is even a totally different vertex. So it's the green one that looks like the diagram that was given to us on the exam paper. Okay, the vertex is 3 comma 1. So it's the green one that works. Okay, so this is what you saw on the test paper, 3 comma 1. So I know the answer is that one, x -3, absolute value +1. So x minus 3 absolute value plus 1. Let me go back to notebook. Okay, it should be loaded back up now. So x minus 3 plus 1 is answer choice B. Okay, that one represents what you see here. Let me just take a second. Are there any questions on doing it this way? Anything at all?
No.
Sure, sit down.
Way of doing this is to just know the equation, which is in your notes from the first week. And the equation, okay, for the vertex of a parabola for actually for a parabola for an absolute value is this. Y equals the absolute value of x minus k, x minus h, excuse me, close up, plus k. Okay, and we learn that this value here, the one inside next to the x, that's the horizontal change. Or the horizontal shift. Let's just call it shift, the horizontal shift. That's the horizontal shift. And then this shift here is the vertical shift. Okay, so I have two shifts here. I have a horizontal and I have a vertical. And what happens is the vertical is actually the easier of the two. The vertical, when you add, when you make k positive, it pushes the graph up. When you make k negative, it pushes the graph down. Okay, so vertical shifting is normal. Horizontal shifting is backwards because of the negative sign. So if you see minus h, it's going to push the graph right. If you see plus h, it's going to push the graph left. So this graph is pushed, okay, based on the regular standard absolute value. Let me make that in black. The parent function normally looks like this. And it's like something like this. All right, that's the parent absolute value function. It shifted 3 right and 1 up. So it shifted 3 to the right and 1 up. So to shift it right, it's going to be x minus 3 because moving right is negative. And then to shift it up, k is normal. Vertical is normal. It's plus 1. So you can see that that's this equation here. This is using the form, okay, the form of the equation to do it. Many students don't like doing it this way, and then you have to also remember this. So if you don't, your best bet is just to use Desmos and then plot it out that way, okay? So you didn't need to use the equation here, okay? You could have just used the Desmos to do it. Now, later on in the year, we'll have more experience doing this and you'll get more comfortable. So my advice for now is to just graph the choices using Desmos and then which one gives you the right picture is the answer. Okay. If you want to use the equation, feel free. But I think now, being that we don't have a ton of experience with this yet, it's probably easier just to use Desmos and faster too. But that's up to you. You know, if you want to use this, you can. If there aren't any questions, I'm going to go to example 2, and you're going to start to notice a pattern of questions that you can just pretty much use the computer in every problem. All right. It's designed, these questions are designed to be done by at least 2 methods. So you have options. All right, let's go to question 2. And question 2, another one. What is the solution set for the equation? And this is an absolute value equation. And we can use Desmos to solve the equation if we want. We absolutely can. How do I know if I'm going to use Desmos, the graphing utility? How do I know when this is equal to this? How do I know when this function, this picture, equals this picture? What will it look like? Anybody have any ideas? Like, what am I looking for? If I'm going to do a graphical solution, what is it I'm looking for?
It's gonna look the same.
Yeah, and what am I, okay, let me graph them both, and then you tell me what you think the values are. So let's graph them and we'll see. let's graph this and graph this in the computer, and then I'll let you guys tell me what the solution should be based on what we see. So I have 3x minus 1 absolute, and then x plus 5. When you're using Desmos, the left side has to go in separate. So let me not use red. It has to go in separate. So in other words, one of the equations is going to be y equals the absolute value of 3x minus 1. And then the other equation is y equals x plus 5. Okay, so we're going to put these two things. This is one equation. This is one equation, one function, and this is the other function. And we're going to see where they're equal. So let's go do that. Let me bring us into Desmos. Doing things graphically, I'm not going to lie, is the easiest way, actually. It's fast and pretty simple. Okay, so let me let it load. Okay, so at this point, Desmos should be loaded up. I'm going to take this away. And like I said, one of the functions was 3x minus 1 under absolute. So you click on the absolute value, make sure the 3x minus 1 is inside. That's one function. And the other one was x plus 5. So line 2, x plus 5. Okay, let me just zoom out so I could see everything. How do I know what the answers are going to be based on what I see?
It's the point where they intersect.
Yeah, it's the point where they intersect. So that's here, right? And here. Okay. Now, please bear in mind, we only care about solving for x. X only. I don't care about y. I just care about x. So in this, x is -1, right? -1's an answer. And over here, 3 is an answer. Why am I not considering 4 and 8? Why am I excluding 4 and 8?
They're the y values.
They're the y values. I don't care about those right now. I only care about the x's. So -1 and 3 are my answers. Okay, -1 and 3 are the two answers. Let me go back to my notebook, and I'm going to write down -1 and 3. So -1 and 3. So x could equal -1 and 3. I see -1 and 3 as answer choice A. It's right here. Okay, this is one way of doing it. All right, this is one way of doing it. There's another way of doing it. You could also solve this algebraically. Okay, that's the other way of doing it. So it's possible that I can solve 3x minus 1 absolute equals x plus 5. I can do this thing algebraically, which isn't hard. Okay, algebraically, to do it that way, I have to get rid of the absolute value. And to get rid of the absolute value, if you can remember back, I have to make two separate equations, two equations. The original, which is easy, that's just 3x minus 1 equals x plus 5. I didn't do any work at all. I just copied what I have. 3x minus 1 equals x plus 5. And the alternative is 3x minus 1 equals, I have to negate the entire other side. Okay, that's the alternative. You negate the other side. So positive x is going to become negative x, and positive 5 is going to become -5. Okay, I negate the entire other side. That is how you remove absolute value, by making two statements. Okay, one statement here, one statement here, and now you have to solve each of these statements individually for x. All right, so to do that, I'm going to bring the x's together. I'm going to subtract x from each side here. And you have options. You don't have to do it exactly the way I'm doing it. There are other ways of doing it. That allows these to cancel out. And 3x minus 1x is 2x. Minus 1 equals, bring down the 5. Then from here, to get 2x by itself, I'm going to add the 1 to each side of the equation to isolate the 2x. That's going to allow these to cancel. And then I'm going to have 2x is equal to 6. And at the end, to get x completely by itself, I have to divide by 2 to isolate it, because this is multiplication, so I divide because it's the opposite, or inverse operation. And when I do that, these 2's can cancel out, and I'm left with x is equal to 3. And I was expecting one of the x's to be 3, because that's right. One of the answer choices is 3 for x, so I know that. So this makes sense. So x is 3. When I solve this one, since I got 3 already, this answer over here had better be -1. Otherwise, I did something wrong, right? Because both approaches got to give us the same answers. Otherwise, something's not right. So this answer here should be -1. Let me make sure. I'm going to remove negative x this time by adding x. And that allows these to cancel out. And when I put these together, I have 4x minus 1, and I bring down -5. And now from here, I want to get 4x by itself, so I have to get rid of the -1, bring that away. Okay, so when I do that, the +1 and -1 are going to cancel out, of course. I can bring the 4x down. And if I do 1 minus 5 is -4, which is the same as -5 plus 1, which is also -4. And finally, to get x all by itself, I can divide 4 on each side to undo the multiplication. When I divide 4 on each side, this cancels out, and x is going to equal -4 over 4, which is -1. And I was expecting that because, right, the answers are -1 and 3, right? Those are the two values that we're supposed to get, and -1 and 3. So we see that doing it algebraically, it's the same thing that we get when we do it graphically, and it better be, right? Otherwise, something went wrong. Now, the problem with just doing it algebraically is sometimes these answers might not work. Now I know they do because I graphed it already, but if I didn't graph it, I wouldn't know if they worked or not. I would have to actually check my answers. So I'm going to check both 3 and -1 back in the original equation just to make sure they work. Okay, so I'm going to check both of them because there's a chance that they might be extraneous. We saw questions like that where it didn't work, so we have to be careful. So I'll check 3 first. The order in which you check is irrelevant. So let me check 3 first. To check, you just take your value and you substitute it into the x's in the original. Once again, to check, you just substitute your answers into x in the original question. Okay, so I'm going to be substituting. I'm going to try 3 first. So 3 goes in here. -1. All I did was substitute 3 in there. I got to put 3 in there also. Okay, so if we work this out, it's pretty easy. 3 times 3 is going to give me 9. And then 9 minus 1 is going to give me 8. And then the absolute value of 8 is just 8. So that was pretty easy. On the right side, 5 plus 3 is just 8. So I can see that the left and right side are in agreement, so my check is valid. They're equal there. So I know that for a fact that 3 works. 3 is a good answer. It makes the statement true. Okay? So I check 3. I know for sure 3 works. I'm going to check -1 too. All right, because maybe it doesn't work. I mean, I know it does because I graphed it, but you wouldn't know that if you didn't graph it. So let's check -1 to make sure that it's valid. So I have to go back to the original, and I'm putting -1 in for x now. So 3 parentheses -1, close parentheses, -1, close the absolute value, equals, what is that? -1 plus 5. Okay, and just like I did earlier, I'll handle the left side first. 3 times -1 is going to give me -3. -3 minus 1 is going to give me -4. And then the absolute value of -4 is 4. Okay, so I have 4 on the left side. On the right side, 5 minus 1 is 4. So it matches up, which means that -1 is a good choice as well. It works. It makes the statement true. Okay, so both -1 and 3 are both solutions to the equation. I've shown it to be true algebraically with all this work here, and I've also shown it to be true with Desmos graphically. So you can see it is a lot faster if you use Desmos and do it graphically. But in case they ask for an algebraic solution, I can always solve it algebraically too. If they ask for an algebraic solution, I would still solve it graphically just to make sure I did just to get the answers, and then I would do the work. Let me take questions. Are there any questions about anything that I've done here so far? Anything? Anything? So just to rehash before I go on, this question could have been done right in 2 seconds by graphing this and this. So for the people who came in a couple of minutes late, if you graph this one and then this one separately in Desmos, I'm going to show it. Okay, which we did a little while ago. Let it load. If you graph 3x minus 1 and then x plus 5, you can see the solutions are -1, that's my x, and 3, that's my other x. So -1 and 3 are my solutions graphically. So this problem could really be done in like a minute, less than a minute. Just put them in Desmos, get the x's, and then write them down and move on. It's pretty basic there. You have to zoom out or just scroll down so you can see it a little clearer. But other than that, I mean, it's really, really simple. All right, let me go back to Notebook if there aren't any questions. Let's go back to Notebook. Okay, let me attach it. Oops. All right, it's loading up. Okay. Anybody have any concerns or anything that they're worried about here, or we're okay?
We're good.
Okay.
We're okay? Okay. All right. If we're okay, I'll move on to the next one. All right. Question 3, another one of those translation questions which we talked about earlier in the year. Which equation represents the parabola shown in the accompanying graph? So we got a parabola here, and we know that the parabola, if you look back in your notes, y equals x squared is the most basic parabola, which opens up through the origin, right? It's something like this. Okay. And this parabola, of course, naturally is shifted somehow. So we have to figure out how this parabola is shifted. My advice is to figure out the vertex. Can somebody tell me what the vertex to this parabola is? Remember, the vertex is essentially, when you're examining a parabola, the vertex is the turning point. So like this right there, the place where it turns, that's the vertex. Can somebody identify the vertex in this parabola?
It's -4.
Yeah. Okay, this vertex right here is the coordinate 0, -4. She's correct, okay? So essentially, this graph is shifted down 4 units, okay? Basically, it's the parent function. It's the same as the parent, the one in green, but pushed downwards. So one of these 4 items is going to take the parabola and push it down and make it go through the coordinate 0, -4. Let me repeat that. one of these four functions here, okay, one of them will give us this black parabola here. It's going to push the parent down 4 units and make the graph go through the coordinate 0, -4 as a vertex. That's going to be true for one of these. So if I don't know the property, I'm going to write the property down, but I won't use it. So if you don't know the property, and here's the property, if you don't remember the property, don't freak out. It's okay. You don't have to worry about it because you can graph all these using Desmos and just look for the proper picture. So that's what I'm going to do. All right. I'm not going to use the property. I'm not going to use the formula that I put there. I won't use it yet. I won't use this right now. I'm going to put these four things in the computer and see which one generates this picture. That's what I'm going to do. So to do that, let's go to Desmos. Okay, I'm going to load. It's opening up. Okay, at this point, I hope it's open. You should be able to see it. And let me get rid of these things. This is from before. And now we have 4 things to put into the computer. We have 4 items. X squared minus 4. Okay, interesting. The turning point for this one, here's the vertex. And it's 0, -4, exactly as the one that was on the test paper. So apparently we got lucky. Choice A was actually the parabola that's on the test paper. I'm just going to put the other ones in just to show you that they're incorrect, okay? The choice B was x squared plus 4. Okay, what that did, x squared plus 4, that pushed the parabola up 4 units, right? This is pushed upwards from the origin. So this is not what's on the test paper. The one on the test paper is pushed down. So this is incorrect, all right? So that's not the answer. So I'm gonna take this away. X squared plus 4 is wrong. I'm just showing you, why it's wrong. The other choices were x minus 4 squared, but in the parenthesis, x minus 4 squared. Okay, that's this purple one. This one is right of the origin. So that's not the answer either. The one we had is down of the origin. This one's to the right. And there's one more choice, which I believe is negative parenthesis x plus 4 squared. X plus 4 and squared. This one is in the wrong location. It's left of the origin. And not only that, this parabola is one that's opening in a downward fashion rather than upwards, okay? So it's wrong in 2 regards, right? It's in the wrong location, and it's even opening in the wrong direction. So the one that's opening in the proper direction and in the proper location is the one with a vertex of 0, -4. That's the blue one, okay? The blue one, which is up here, x squared minus 4. Therefore, we know x squared minus 4 is going to be the answer. I'm going to go back into Notebook and write down x squared minus 4. Okay, so now it should be loaded up. So I have x squared minus 4, which is answer choice A. Now, why is it answer choice A if you're doing it with the formula and not doing Desmos, which I don't recommend. I highly recommend you use Desmos. But if you want to use the equation, we know that H is the horizontal change. It's the horizontal shifting. And K is the vertical. So for those of you who want to use the equation, this graph is not shifted horizontally at all. It is not moved left or right. It's just moved down only. So the horizontal change is 0. It's not shifted horizontally. So x minus 0 squared, because it's not moved left or right at all. It is moved down 4 units. So K is -4. If you work this out, subtracting 0 is meaningless. X minus 0 is x, so you get x squared minus 4, which is what you have right here, all right? That's using the equation. And you can feel free to do it however you want. All right. I'm not gonna. That's why I put these questions there to allow you the freedom to choose a strategy that you want to use. All right. So I think doing it with Desmos is a little easier, but if you're comfortable using this equation, then by all means use the equation. Any questions? Anything?
No. No.
Okay. So if there are no questions, I'm going to roll on to number 4. And so far, all 1 for 1, 2, and 3, you could have used Desmos for all 3 examples. Okay. Question 4. Question 4 is going to look like the stuff we've been doing very recently, right? It's the stuff from yesterday and this week. Okay, this is all the information all the stuff that we've talked about this week, which is solving these equations with 3 variables, which I know can be a little annoying. So if you look, find the values of x, y, and z given the system of equations above. And wow, this is your hint to use technology, because even the answers are written in this form, in the technology form, in matrixy form. So they're telling you, they're basically suggesting, not telling you, they're suggesting you use technology by the way they have the answer choices listed. Can you do this by hand? Yes. Should you do this by hand? Well, that's up to you. Just know if you do it by hand, if you do it algebraically, it's going to take you quite some time. All right. Where if another student decides to do it with the computer, they're going to finish a lot faster than you're going to finish. So it's pretty advisable to do this with the computer. Now, the thing is, if you want to use the computer to do it, it's not Desmos just by itself. You have to type in Desmos matrix, right? It's a different thing. Okay, it's still ran by the same company, but Desmos matrix for this one. Okay, I'm sure there's a menu or a way to do it from the graphing calculator. I'm just not sure how. So if you just do a search, Google search for Desmos matrix, it comes up right away and you can put everything in. Now, remember, if you want to use Desmos matrix, you need to make an augmented matrix to put the values into the computer to tell it what to do. And before you do that, you have to make sure everything is in standard form. And I believe that it is. X, Y, Z, constant. X, Y, Z, constant. X, Y, Z, constant. Everything has X, Y, and Z. There's nothing missing. It's in the right order. Everything is the way it's supposed to be. So this problem came in standard form. All right. It was given to you, provided to you in standard form. Thank goodness. So we can go straight to making an augmented matrix. I'll do the top line, and then I'm going to have somebody else do the second and the third row. So the first row for the matrix is going to be 4, 3, 1, -4. Somebody want to give me row 2?
2, -1, 3, 18.
Thank you. And then I'll take another volunteer to give me the final row.
-2, 4, 1, -7.
Thank you. So now that's everything. We got everything we need. Our augmented matrix is ready to go. All we have to do now is go in to Desmos matrix, drop this stuff in there, and poof, it's going to give us the X, Y, and Z, the values we were looking for. So let me go do that. Let me go to Desmos matrix. Desmos matrix calculator. Okay. So I have that open and running. So when you log into that, this is what you're going to see, right? This is it. So to do this, you have to make a new matrix. Click on that. And whenever you open up a new matrix, it defaults to a 2 by 2, which is not okay for us, right? That's we can't get our information in there. Our equation had 3 rows. We have 3 equations, so I need 3 rows. Okay, so just change it to 3. And then we have X, Y, Z, and the solution. So I need 4 columns. Okay, I need X, a column for X, a column for Y, a column for Z, and then a column for the solution value. So I need 4 columns. So once I have my 3 by 4, now I'm ready to put the information in. Okay, let me look back. the first row, I have 4, 3, 1, negative 4. 4, 3, 1, negative 4. 4, 3, 1, negative 4. My second row, I have 2, negative 1, 3, 18. 2, negative 1, 3, 18. 2, negative 1, 3, 18. So that's that. And then my last row, I have negative 2, 4, 1, negative 7. Negative 2, 4, 1, negative 7. Negative 2, 4, 1, negative 7. Okay. Please, please, please make sure your data is in correctly. Once it's in correctly, then you hit enter, which is this blue key down here. So now my information is entered into Desmos, and I want to solve this system. So entering won't solve it. You have to tell the computer what to do. So I need to do RREF, reduced row echelon form is what that stands for, RREF. And I'm doing that on A because I put my data into matrix A. And it works out beautifully. I have my 1, 0, 0, 0, 1, 0, 0, 0, 1. So diagonals of ones and zeros every place else. It comes out exactly as I want it to. And I have 0 for X, negative 3 for Y, and 5 for Z. So X is 0, Y is negative 3, Z is 5. Once again, X is 0, Y is negative 3, Z is 5. X is 0, let me write this down. X is 0, Y is negative 3, and Z is 5. Okay, I'm going to bring us back to Notebook. Let's go back to Notebook. And let's load it back up. And here we are. We're back in Notebook now. So X is 0, Y is negative 3, and Z is 5. This is incorrect because the signs are wrong. This is incorrect. This is missing the negative sign. Ah, here it is. 0, negative 3, and 5. 0, negative 3, and 5. So it's choice D. Any questions there? Anything at all? Now, you could do this question algebraically, but if you do it algebraically, it's going to take you significantly more time, which is fine. You can do it algebraically if you want. I'm going to do one on Monday algebraically because I want to show you one more question today before we go, so that I can be in the same place with my morning class. I didn't do it algebraically with them today either. So I'll do this question again through algebraic means on Monday. All right, so you get to see it. It just takes a long time to do it algebraically. It's like 10 minutes, even a little longer. Okay, so that is that one. Yeah, much faster using technology and using the augmented matrix.
Mr. MPZ,
Yes, yes.
you said there's gonna be office hour, like office
Oh,
hours
yes,
today,
yes,
right?
there are. Thank you for reminding me. Office hours today. So let me put this in the chat. Office hours are today. You need to email me though, okay? So
Okay.
office hours today. It's going to start at Let's make the start time. Start time. I think I'm going to make it 2:15. As long as I have no meeting, I can start at 2:15. And they didn't say there was a meeting, so office hours today. Start time will be 2:15. You must email me, okay? So I can add your name to the thing.
Okay.
All right. So if you email me saying I want to be part of the office hours, then you'll get a link, right? Like I give you for these sessions, you'll get a link that allows you to enter that. And there's no mandatory time. You stay as long as you need to. It's really, there's no set thing for me. You can just ask me questions about anything you want, and then I'll go over that, right? So I'm not gonna like come to like a lesson or anything because it's for you, not we do that. I come with a lesson here, so it's to answer your specific questions, even if it's not regarding what I'm doing right now. It could be something from the past, whatever you want.
Okay.
Okay. All right. So the people who said okay and all right, please make sure you email me so I know to add you to that list. Okay. So just shoot me an email. Once I get the email, I can cut and paste your email and make an invitation, because that's how the invitations get made. They don't get made by your name; they get made by your email. So when you email me saying please add me or whatever, like add me, or just say I want your office, give me the office hours for today, whatever, anything that lets me know you want the office hours for today, then I'll add you in. I'll just cut and paste your email into Google Calendar and it'll give you a link. Okay. So let's see. This is the last example. We only have 4 minutes. This was pretty quick. So just to note, question 1, computer. 2, computer. 3, computer. 4, computer. We've done 4 examples. All 4 could have been done using the technology, okay, if you wanted to. Or they could have been done by hand. So you have the option so far for every question. And this looks the same. The table of values below can be modeled by which equation? So they gave me this table of values, okay? And they want to know which of these equations models this table of values. So what I'm going to do is, because time is kind of running out, I'm just going to make this myself. It's really easy. And then I'll use technology to see which one of these creates the graph I get from plotting these points. So all I have to do is really plot these points. That's it. I'm just plotting points. So let me just grid this out. 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. Sorry, it's not scalar. Okay, can someone just tell me where is this located? Where is -2, 5 located? Like, how do I find -2, 5?
Go left 2 and up 5.
Thank you. Go left 2, and up 5. So how about right there? Thank you. -1, 4. Isn't that just left 1, up 4?
Yeah.
And then 0, 3, I don't go left or right. I just go up 3, right? Like there. 1, 4 would be right 1 and up 4. And then 2, 5 would be right 2 and up 5. Okay, I'm just going to connect these. So if we connect this, okay, and if we connect this way, okay. So it's not perfect because my dots aren't perfect. Okay, what does this look like to you, this thing?
A parabola.
Oh, okay. So yeah, it could. My diagram isn't perfect. It's supposed to be V-shaped and not U-shaped. So it's supposed to be absolute value. Sorry about that. My diagram's just not the greatest. If you take your time and you're neater, a little bit neater than I was, you'll be able to see the V shape a little better. It's not supposed to be U, so it's not supposed to be a U shape. I'm sorry, my diagram's kind of crappy, but it's supposed to be absolute value. Then you want to figure out which one of these would represent this. Which one would give you this? Okay, would it be A, B, C, or D? Well, the good news is I never taught you how to do functions with respect to Y. So it's not going to be B or D because you didn't learn this yet. This comes later in the year. So this is not possible to do these. Is it A or C? You have to figure out if it's A or C. Now, the good thing is you can figure out if it's A or C without memorizing anything. You can simply plot this and see which one gives you the diagram. This is 3 units above the x-axis, correct? We are 3 units up. We're 3 units up. The parent function would normally be here. So we are 3 units up from the origin, okay? So we have to see which one of these gives us 3 units up from the origin. I'm going to put both of these into the computer really quick, and then we're going to be done. So Desmos Graphing, and the 2 things, let me clear this stuff out. The 2 choices were x plus 3, where it's inside, where the plus 3 is inside, x plus 3. That's one possibility where it's inside. And the other one is x on the, and plus 3 is on the outside. So you can see, hopefully, that the blue one is the one that's pushed. The blue one is the one pushed up 3 units, okay? It's the blue one. The red one is pushed left 3 units. That's not what I want. I want to be pushed up 3 units, and absolute value of x plus 3 is pushed up 3 units from the origin. This matches what I see in my diagram that I sketched. So I can simply just go back there really quick, and I can circle the fact that it's this one. All right, and not for nothing, we can figure that out because there's an equation which we saw a little earlier today, right? And we know that k is the vertical change. This is shifted upward 3, so it's k that's getting moved. K, the outside number, is 3. All right. I'm sorry. I want to be respectful of your time. Let me just stop the recording. Please, if you need to be in the review session, please shoot me an email. I will add you to that. That's not a problem. I haven't gotten any emails yet, but when I get them, I'll add them. And the session will be at 2:15. Yes, question.
Can I email you on PeoplePath, because I'm trying to put your email in Gmail and it's not coming up. It's giving me a student's email.
Hang on, let me give my email right now. Hang on, I'm gonna put it in right now. MRPC2 at schools.nyc.gov. Okay, let me enter this. Can you see it now?
Yeah.
That's my email. So please email me through there, and then I'll add you. I'll add you to the list. Okay.
Okay. Mr. MPZ?
Yes.
Do I still need to email you?
If you want to be in the office hours, then yeah, because I just need to cut and paste your email.
Okay.
Okay, so please, that's why I'm doing it that way, because otherwise I can't. It won't let me put it in by name. It's the way the system is set up. It's by email.
Okay.
All right. So please email me if you're interested, and I will set it up, and you'll get an invite. You'll get an invite today. Okay, in a little while. All right, guys. That's all I have to say. I'll continue finishing this review session on Monday. Please enjoy the rest of your day. I'll see some of you later, and if I don't see you later, then have a nice weekend. All right, please be safe.
Bye, Mr. MPZ. See you later.
Bye.
Bye, everybody. Bye, everybody.